Let's talk about exponential function. Okay, so like you have to understand about the increasing function and decreasing function. Okay, so look at the like first problem A, and when x is increasing and y value is increasing, right, and it is curve. And also another important feature is like your y value or your graph never be under the x-axis. Okay, then this is like a basic property of the exponential function. Okay, so to talk about a and b, like basically a is exponential growth and b is exponential decay. Is that okay? So now, like when you look at c and d, then you can find the definition of the exponential growth and decay. Okay, it is here. So look at that. And C and D has the same function, which is B to the x and A to the x. So we say B and A's are the base. And whenever you have x on the power position, then that is exponential function. Okay. So whenever your base is bigger than one, then we're going to say it is exponential growth. Let me write, okay? And whenever your base is between 0 to 1, and we will say exponentially decay. Okay, but keep that in mind, your base cannot be zero or negative. Also, like your base cannot be one, because your base is one, it is not funny, right? Because like one to the power is always one, right? And zero to the power is like we cannot decide zero to the power equals zero, right? And negative power, negative base, then it will be oscillated with a like an even power or odd power, right? So that is the reason why we are not going to talk about, okay? Your base must be bigger than zero and not equal to one, and we have like two interval then, right? 0 to 1 and bigger than 1. Okay, 0 to 1 case, which is like problem C, is the exponential decay. Okay, think about it. Like for example, and like think about any number which is between 0 to 1. Like for example, 1/2. Okay, the 1/2 to the 1 is 1/2, right? 1/2 squared is 1/4. 1/2 cubed is 1/8, and 1/16, 1/32, 1/64, dot dot dot. Right? Do you understand what I'm saying? Okay. Your denominator is getting bigger, but numerator is just one, which means it's getting smaller, smaller, smaller. I'm not talking about negative number, okay, but getting close to zero. Right? That is the reason why the name of like the case C is exponential decay. Okay. Then D case when A is bigger than one, like for example 2. Okay, even if it's 1.1, just a little bit bigger than 1, doesn't matter. Same situation, okay? 2 squared, 4, 8, 16, 32, getting bigger and bigger and getting close to the like infinite, right? That is exponential growth, okay? So the answer for like actually the graph of like D is A, okay? This is the graph of D, and like B is the graph of C. Is that clear? Okay, let me give you like a couple of more example. Here we go. E is the, like exactly the base is bigger than one case, right? So this is the exponential growth. Okay, and look at F. Your base is 1/4, which is between 0 to 1. That is exponential decay. Okay, and look at G. It's a little bit tricky, right? But look at the power. It's negative x, right? So we can rewrite this one as 5 to the negative 1 to the x, which is 1/5 to the x, right? Which means it is an exponential function, but your base is between 0 to 1. That is the reason why this is exponential decay. Okay. And then HO, another negative power, right? So we can do like this way. 3/8 to the minus 1 to the x, right? I just split your power as negative nx, right? So that is equal to 8/3 to the x, right? That is exactly exponential uh, growth because your base is 8/3, which is bigger than 1, right? So look at I. Even if it's decimal number, doesn't matter, okay? As long as your base is bigger than 1, it is exponential growth, right? And then your base is like between 0 to 1, but there is negative power. So we can think like this one is like that. and 1 over point 0.024 to the x, okay? 1 over 0.024 is bigger than one number. That is the reason why this is exponentially growth, okay? And then look at that. In the same situation, okay? So like your power is negative. So this is equal to 1 over c to the x. You understand what I'm saying, right? And if your c is bigger than 8.5, it is 1 over 8.5, okay? 1 over 8.5 is your base, which is like in between 0 to 1. So that is the reason why this is exponentially decay, okay? And then D is obvious, right? Between zero point 0.5 to zero point 0.9, which is between 0 to 1, right? That is the reason why this is exponentially decay.